If you're an aerodynamicist or structural engineer in Stuttgart, Maranello, or Woking right now, there's a real reason to be nervous. For over half a century, the hypercar world has followed a rigid rulebook. If you want extreme cornering performance, you bolt on massive wings. You accept drag, sacrifice top speed, and trade efficiency for raw downforce. That compromise has defined European performance engineering for decades. Then came the Beijing Auto Show 2026, and that entire philosophy got flipped on its head. Xiaomi didn't just launch new cars, like the Xiaomi SU7 Ultra and the Xiaomi Vision GT. They introduced a fundamentally different way of thinking about performance itself. This isn't about acceleration times or flashy screens. It's about tearing down the engineering behind what they've built, because it goes far beyond a fast EV. Xiaomi has blended aerospace-grade fluid dynamics, advanced metallurgy, and unconventional structural design to challenge the core principles of automotive physics. And yes, the traditional rear wing might actually be on its way out. To understand the scale of this shift, you need to look at how downforce is traditionally created. In a typical hypercar, air hits a front splitter, gets disrupted, and is forced over a large rear wing to push the car downward. It works, but it also creates massive turbulence and drag. It's effective, but inefficient. Xiaomi's engineers, many with roots in European performance programs, decided that external aero components were the problem, not the solution. Instead, they adopted a concept inspired by aerospace, the lifting body. Aircraft, like stealth bombers, generate lift through the entire shape of the fuselage, minimizing reliance on large wings. Xiaomi took that idea and inverted it. By separating the cockpit from the front and rear structural elements, they created a design where air doesn't just flow around the car, it flows through it. High-speed air is channeled underneath the chassis through extremely tight, sculpted pathways, accelerating as it moves. As velocity increases, pressure drops. This creates an intense, low-pressure zone beneath the car, effectively pulling it down onto the road without relying on external wings. The result? Massive downforce, generated internally with far less drag. In performance engineering, there's a key metric: aerodynamic efficiency. It measures how much downforce you generate relative to the drag you create. Top-tier track cars usually sit around a ratio of 3.0. That's considered elite. The Vision GT reportedly reaches 4.1. That number shouldn't exist under traditional models. It means the car produces extreme downforce while maintaining exceptional aerodynamic cleanliness. In simple terms, it grips like a race car, but cuts through the air like a low-drag prototype.
High-speed cornering introduces another problem: crosswinds. At extreme speeds, even minor airflow disruptions can destabilize the car. Xiaomi addressed this with a vertical stabilizing fin, similar to endurance race cars, and an advanced boundary layer control system integrated into the rear lighting structure. Micro-scale airflow manipulation helps maintain stability by controlling turbulence behind the car. Even the wheels are engineered differently. Instead of traditional aero discs, the outer surfaces remain static, while internal structures rotate, functioning like turbines. They pull cool air into the brakes and expel heat without disturbing airflow. It's not just aerodynamic design, it's total airflow management.
All that performance is meaningless if the chassis can't handle it. Xiaomi didn't just tweak the structure, they rebuilt it entirely. Instead of relying on simple crash load paths, they created a multi-directional energy distribution system. In a collision, forces are split and redirected through multiple channels across the structure. And the materials? ultra-high-strength steel rated at 2200 MPa, stronger than what's used in some submarine pressure hulls. The cabin structure forms a tightly integrated safety cage designed to resist deformation under extreme stress. The result is a chassis engineered to absorb significantly more impact energy than standard global safety requirements demand.
Battery safety has always been a critical issue. A punctured battery can trigger thermal runaway, leading to extreme temperatures and uncontrollable fires. Most manufacturers respond by adding protection plates. That adds weight and reduces efficiency. Xiaomi took a different route. They designed a multi-layered defense system. A high-strength aluminum honeycomb structure absorbs side impacts. A reinforced crossbeam at the front breaks apart road debris before it reaches the battery. And underneath it all, a ballistic-grade protective coating. This isn't marketing fluff. It's essentially armor technology applied to an EV battery pack. Even under extreme stress tests, the system is designed to contain failure rather than escalate it. All of this engineering leads to one uncomfortable conclusion for traditional automakers. The rules have changed. For decades, legacy manufacturers believed their expertise in aerodynamics, chassis tuning, and performance engineering couldn't be matched by tech companies. But Xiaomi didn't just catch up. They approached the problem differently. By combining computational fluid dynamics, aerospace design principles, and advanced materials science, they've challenged assumptions that have stood for generations. When a company can build a high-performance machine that behaves like a race car, stabilizes like an aircraft, and protects like an armored vehicle, the implications are clear. The era of brute force aerodynamics is fading, and the future belongs to those who rewrite the physics, not those who follow it. If this is what happens when physics gets rewritten, imagine what happens when power is the only goal. We've already ranked the 10 most powerful hypercars on Earth. Check it if you think this was insane.